Started. Good morning to all. Myself, Dr. P. Gopinath, Assistant Professor, Selection Grade, Department of EC, Department of ECE, KIT, Kalanar Karunanidhi Institute of Technology, Coimbatore. Today I am going to handle the subject is a B23 ECT 404 Digital Signal Processing. So that is the first unit is a discrete Fourier transform. So last class we have seen what is DFT and IDFT, Tudel factor, based on problems. Today we are going to see that circular convolution. So convolution means we have performed multiplication, multiplication of two input data. So normally convolution consists of two types. First one is a linear convolution. Second one is a circular convolution. So now we are going to see the circular convolution topic. While performing linear convolution, if both the signals are periodic, then it is difficult to obtain other convolution. Even though we obtain such convolution, it becomes meaningless. In the circular convolution, for periodic signal, convolution can be performed with periodic averages. When both the signals are periodic with period n, the convolution result is also periodic with period n. The circular convolution can be calculated by following methods. First one is a graphical method. Second one is a matrix method. Third one is a DFT and IDFT method. First one, we are going to see that a graphical method, or another name is concentric circle method. So in this concentric circle method, we are using mainly formula, that is a x3 of n, that is equal to n equal to 0 to n minus 1 x1 of n into x2 of m minus n. So this is the formula. Then based on that, this is a graphical representation. We have performed first, we have plot x1 of n clockwise direction and x2 of n also clockwise direction. Then we have multiply sample, that is a point to point samples we have multiplied, and addition should be performed. Then and only we have get one output of the first sample. Then similar fashion we have rotate the samples, that is a x1 of n and x2 of n anti-clockwise direction. Likewise, we have obtained remaining samples. So in this problem, the two sequences x1 of n and x2 of n. The x1 of n sample is 2, 1, 2, 1, and x2 of n equal to 1, 2, 3, 4. Find out the sequence x3 of m, which is equal to circular convolution of about these two sequences. Then solution of this problem using circular convolution formula. Before that, we have checked the input values. In this circular convolution, both the input values are equal. Then and only we have proceed the next step. If not equal, we have add zeros. That is zero padding. So that is important 2 mark question. Then first step, to find x3 of 0, we have substitute n equal to 0 to 3. M value we have substitute 0. So in this equation, x3 of 0 equal to n equal to 0 to 3 x1 of n into x2 of minus n. So you can see the diagram. That is a first we have plot x1 of n anti-clockwise direction. X1 of, this is the point, that is a x1 of 0, then x1 of 1, x1 of 2 and x1 of 3. Then similarly, that is a x2 of n. We have draw that. After that, we have multiply. It is a 4-point samples. So we have multiply two samples x1 of n and x2 of n like this. Then after multiplied the values 1 cross 4 equal to 4, 2 cross 1 equal to 2, then 1 cross 2 equal to 2, 2 cross 3 equal to 6. So first value we are applying m equal to 0, that is a x3 of 0 for the first iteration, 2 plus 4 plus 6 plus 2. The x3 of 0 answer is 14. Then similarly x3 of 1, x3 of 1 equal to 4 plus 1 plus 8 plus 3, that is equal to 16. That is a x3 of 1 value 16. Similar fashion, x3 of 2 answer is 14, x3 of 3 answer is 16. So this is the output sequence x3 of n value. So the 14 comma 16 comma 14 comma 16. So this is the circular convolution output for 4-point samples. This is the first method, that is a graphical method or concentric circle method. Similar fashion we have solved remaining method also. That is a second one is a matrix method. This matrix method we have performed ex we have a two input sequence, the given problem. For the same problem we have considered x1 of n equal to 2 comma 1 comma 2 comma 1, then x2 of n equal to 1 comma 2 comma 3 comma 4. So these are the two input samples, both length are equal. So we have proceed using matrix method. In this matrix method we have utilizing x1 of n taking DFT using matrix formula, then x2 of n we have taking DFT. Then we have obtained x3 of k. So x3 of k is the multiplication of x1 of n and x2 of n of DFT samples. So that is a x3 of k will be obtained. Then after x3 of k value we have take inverse Fourier transform, that is a x3 of n we have obtained. So that is the output of circular, that is the circular convolution output. Then third method, DFT and IDFT method. So this is the DFT and IDFT method. We are using direct formula. So these are the steps we have followed. First one, calculate n maximum of n1 comma n2 length. Then obtain x1 of k from x1 of n by applying n point DFT. Then third one, obtain x2 of k from x2 of n by applying n point DFT. Then fourth step, obtain y of k, that is equal to, we obtained x1 of k and x2 of k. Then fifth step, take n point IDFT for y of k to obtain y of n. Now y of n is the output of the circular convolution of x1 of n and x2 of n. So here, using matrix method related problems, you can see that x of n we have denoted 1 comma 1 comma 2 comma 1. Then h of n equal to 1 comma 2 comma 3 comma 4. Perform the circular convolution using DFT and IDFT. So here we have obtained using cyclic property, we have denoted matrix W4 value. In this W4 matrix value should be denoted 1 comma, that is a 1 1 1 1, then 1 j, that is a minus 1 minus j, 1 minus 1 1 minus 1, then 1 minus j minus 1 j. So this is W4 value. Then after we have performed our x of n samples 1 comma 1 comma 2 comma 1. So using row and column wise multiplication, we have obtained the answer is 5 minus 1, 1 minus 1. Then one more second input data, we have performed likewise 1, 2, 3, 4. So we have obtained the output value. We have denoted y of k. Y of k equal to x of k into h of k. That is equal to 50, comma 2 minus 2j, comma minus 2, 2 plus 2j. So this is y of k value. So in this part, that is first part, we have taken DFT. Then second part, we are obtaining IDFT. To find IDFT of y of k, they're using matrix IDFT formula, y of n equal to 1 by 4 w4 star. So here star should be indicated. That is a complex term. Sign should be changed. Then x into x4. So here 1 by n value, we know that that is a 4.1 by 4 of matrix value already created. Then x4 we have denoted obtained value of DFT sequences, that is a 52 minus 2j minus 2, that is a 2 plus 2j. So after we have performed row and column wise multiplication, the final answer is 13, comma 14, comma 11, comma 12. So this is matrix method, and also we are using DFT and IDFT method, means we have directly substitute the same step instead of matrix formula. So direct formula, we know that for DFT, discrete Fourier transform formula, that is x of capital X of k equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi nk divided by capital N. So using the formula, we obtain the first sequence. Second sequence, we are applying the same formula. Then we have performed DFT first stage. Then after we have multiply the two sequences, that is the term y of k. Then y of k, we have taking inverse discrete Fourier transform formula. So we know the inverse discrete Fourier transform formula, x of n equal to 1 divided by n summation k equal to 0 to n minus k equal to 0 to n minus 1 x of k e power j 2 pi nk divided by capital N. So this is the formula we have obtained using DFT and IDFT method. So this is the topic we have covered in this session. Circular convolution. Circular convolution is normally we have performed a multiplication of two sequences. It consists of three methods: graphical method, concentric circle method, graphical or concentric circle method. Then second one is a matrix method. Third one is a DFT and IDFT method. Then first initially we have checked the problem. Uh, Length must be equal, then and only we have proceed the problem. That is our initial stage. If not equal means we have equating adding zeros, that is called zero padding. That is an important 2 mark question. Then based on that we have follow the three methods we had seen in these examples. Okay, so that's all circular convolution. Thank you.